Hello, welcome to Chapter 8b, More Time Value of Money. Well, I gotta tell you, I have good news and better news. The good news is if you're only interested in two cash flow projects, you can stop this course, you can quit Miami University, you can go out and specialize in two cash flow financial projects, and you know already everything you need to know about them. So the better news is some of you might be interested to be more general and learn about and know how to understand cash flow projects with more than just two cash flows. Most projects turn out to have more than two cash flows. So if you're interested in that, you should hang on through this chapter, and then you'll be able to analyze and solve a much larger class of problems. So let's get started. All right, so like I just said, most problems involve more than just two cash flows. So we call these problems multiple cash flow problems. And more good news here is that we can solve these really easily by just treating them as sets of two cash flow problems. So let's jump right in with an example as usual. How much would an investor pay now to purchase a bond returning $6,000 in 1 year and $8,000 in 2 years if there's an interest rate on the bond of 10.4%? So let's see what we can do with this one. First of all, let's make a cash flow diagram for the investor. So we've got now time on the x-axis. We have our CF0, the amount that's going to have to be invested at time 0 to what? Grow into a piece of 6K after 1 year and 8K after 2 years. And we could call this CF2 and we could call this CF1. And let's keep going with this. Really, what we've got here at CF0 is that we have a chunk of CF0 or a tranche of CF0 that is going to grow at the interest rate of the project into that 6K that we're going to get out after a year. And then we have another tranche here that's going to grow for 2 years into this 8K piece. So what we could do is we could call this tranche A and we could call this tranche B, and then it would be true that the total amount invested for this deal is A plus B. And now it's looking to me like we have something that we can completely solve just using everything we learned in the previous chapter, right? So we can solve for A like this. A is equal to, we just need to discount it back by 1 year. So that's going to be using the present value, future value equation. The present value is equal to the future value divided by 1 plus r raised to the amount of time we're discounting by. So this is 1 plus, I'm claiming early onset Alzheimer's here and looking back for our interest rate, which is 10.4%, 10.4%. Okay, and B is equal to, same thing, we just got to slide that back in time to t equals 0, our 8,000 back in time to t equals 0. So that's going to be our 8 divided by 1, whoops, yep, plus 10.4%. And this has to be discounted back for 2 years. So let's go ahead and see if we can get this going. I'm going to slide an Excel worksheet over for us here. So I'm going to say equal 6 divided by 1 plus 10.4% plus 8 divided by 1 plus 10.4%. And yes, of course. And there we go. We get 12.68. Okay. And Okay, so let's use Excel to perform these calculations and see what we've got here. Okay, so for A, we have okay, 5.44, and for B, we have our 8,000 divided by 1 plus 10.4%, and that needs to be raised to the 2, and then we add those up to get CF0, and we get 11.99853. That's close enough to 12 for me. So that's equal to 12K. So you see how very straightforwardly we're just using what we learned in the last chapter successively now to solve multiple future cash flow problems. All right, let's go on and see what I have down here for text on the next couple of pages. All right, so CF0 equal PV total amount the investor pays now, right, which is comprised of that tranche A and that tranche B. Tranche A grows into 6K, tranche B grows into 8K. Each tranche is growing at 10.4%, and we did the work on this, and I'll just bring in Excel here. So 5.43, 6.56. Okay, so 5.43, and here we have 6.56. All right, and our total is equal to 12.0. Talked about that enough. I'll just leave it here so you can see it. You can read this over if you need to. So now what I'd like to do is build from that example and develop for us a general case for projects with multiple future cash flows. Okay, so we want to say that when we've got a problem and we want the present value of a set of future cash flows for that project, in words, what that always is just the sum of the individually discounted cash flows, okay? And what we mean by that is discount each future CF first, then add them up. Okay, so now let's do some definitions and see if we can get a formula. For a future set of cash flows for a project, CF1 to CFN, we'll say PV tot is equal to CF0. It's the total present value for this set. It's the sum of the individually PV'd discounted cash flows, okay? So this is so important. I'm gonna just put it again down here, okay? Discount each future cash flow first, then add them all up. So now we can take that general concept and use summation notation and get a general formula for us. So that's going to look like this. PV tot equal CF0 equals, this is the sum of all the cash flows, where before we add them up here, see for cash flow I, we discount it by 1 plus R to the time of that cash flow. So I goes from 1 to the number of cash flows, which is N, and TI is the time of cash flow I. This equation, this is another one of our big deal equations. So this is called the fundamental discounted cash flow equation. And just looking at this equation, there are a few things we can say about it. If we're given all the future cash flows and we're given R, clearly we can easily compute PV tot or CF0. Okay, so we've got that figured out. How about if we know PV tot and we know R, and what if we know all the future cash flows are the same? That's going to happen a lot. If that's true, then we can pull this constant number out of the summation sign, and in that case, we're going to be able to solve for that uniform cash flow. And we'll see how to do that in just a second. And what's the other possibility? We could know PV tot and we could know all the cash flows. What else is missing? It's R. So we could solve for R. That's going to be a little bit tricky. We're going to need to use something like goal-seek in general to do that in Excel, or use something like the quadratic equation in some cases. Okay, so let's think about the meanings of the fundamental discounted cash flow equation. Always good to think about from a lender's perspective and a borrower's perspective. So from a lender's perspective, that would be someone purchasing the bond, right, in the above example. So CF0 or PV tote is the amount that she invests now in order to receive that future stream of cash flows. And another thing that is good to remember here is that CF0 we found was equal to 12K, and the uh, the key thing to remember about that is that it better be less than the sum of the future cash flows. So we have a plus 6 is 14 in most circles. So without any time value of money or anything, she's putting 12,000 in the deal and she's getting a total of 14,000 back. Again, all the qualitative things that you can think of in finance work directly with the math. Okay, the math follows your qualitative sense or your intuition. Okay, so far so good with that. And the second thing from a lender's perspective is if we have a constant PV tote or CF0, as R increases, our future cash flows go up, which sort of makes sense, right? The higher interest rate a lender can charge, the more money they're going to get back in the future. So that comes from the math, and again, it follows with our intuition. So that leads us to the important question, should a lender always try to maximize R? Well, maybe not. Okay, and the reason for that is the higher interest that you charge, what's going to happen? First of all, there are going to be competitors in the marketplace. If you're JP Morgan Chase, you've got Wells Fargo, you've got Morgan Stanley, et cetera, et cetera. So they're going to maybe come in with slightly lower interest rates than you. And what also is going to happen importantly is that if you have really high interest rates, all of the entities and people that are good credit risks, quote unquote, that have a low probability of flaming out, are going to be with your competitors at a lower interest rate. So you're going to wind up lending to much riskier borrowers with a higher probability of them flaming out. So there's two reasons you might not want to maximize your R. One is you price yourself out of the market. Okay, and the other one is, if we can correct my spelling there, you price yourself out of the market, number one, and number two, if you don't do that, you wind up with risky borrowers. Risky borrowers who may flame out. That's why they're risky. They have a higher probability of having to not follow through on all the terms of the contract. So now let's think from a borrower's perspective. From the borrower's perspective, that would be the seller of the bond. The seller of the bond gets a big pile of money in the beginning, right, in return for paying back more cash in the future. Okay, so first thing is CF0 is the amount that if we're the borrower, we could get now if we agree to pay back more in the future. Okay, and with the future cash flows constant, as our interest rate goes up, the cash flow zero, the amount we can get at t equals zero, goes down. This is a good way to think about it because the way lenders think about it is they'll ask the question, how much can this borrower pay back without flaming out, without going bankrupt, right? So that's how they're going to set things up for you. And so then you know, for example, you can pay $10,000 back a year and that's all, okay? So if you have a very low interest rate on that, you'll get a big pile of money from the lender initially. If you have a very high interest rate, you'll get a smaller pile of money. And of course, you want the bigger pile of money because maybe you're going to buy a house with that or something, and you want the best house that you can get. So as a borrower, you're interested in how do we reduce our interest rate, the interest rate that we're being charged. Okay, so for entities, mainly two things. Be cash flow positive and have low debt to cap. Okay, so lenders are going to want you to be cash flow positive and to not already have a lot of leverage on your balance sheet. And for personal, okay, for mere mortals like you and me, really the key thing right now is have a good credit score. All loans for individuals and families are based off that individual's or that family's credit score more than any other variable. So a good idea to get and maintain a good credit score. All right, so let's jump right into an example here. We've got Velocity Advisors back in action. They're offering to pay you $6,000 at the end of next year. Okay, that's EOI1, and that'll be CF1. And at the end of 2 years, $12,000. And in return, you pay them CF0 now. So you're the lender, they're the borrower. And the interest rate that they're giving you on this deal is 10%. So let's find cash flow diagram for us, okay, and let's solve for CF0. And then if we just have 15,000 to invest, that's all we got, okay, can we participate in this deal or not? So let's find out. So for our cash flow diagram, you guys know the story here by now. We put in time on the x-axis, and we're going to put this here, and we're going to put this here, and we're going to put our CF0 there. Okay, so now we've got our 6K. They're claiming that they're going to pay us if they don't go bankrupt or become fraudulent and take our money and run down to the Turks and Caicos, never to be seen again. And there's our CF0, right? And as usual, this is going to be CF0 comprised of these two tranches, right, A and B, that are going to, whoops, hang on, let me draw these two tranches here, that one, and here's a bigger one. Okay, something like that. And A is going to grow into the 6K and B is going to grow into the 12K. So as usual, CF0 will be equal to A plus B. All right, so there's our basic cash flow diagram. Okay, and what's the total amount you pay now to be the, yeah, what's our total amount we pay now? I don't know what's going on with that wording. Ignore that wording. Let's just figure it out. So CF0 is, we're going to have to take that 6K, okay, and divide that by the interest rate on this deal is 10%. So 1 plus 10%, and that gets discounted back by 1 year, plus that 12K, which gets discounted back by 2 years. Okay, so this is, what is this? This is A plus B. So let's bring this over in from Excel. And see what we get. Okay, 15.37. So, all right, so that's B. That's how much we would have to put into this deal to get back 6,000 in a year and 12,000 in 2 years, right? So there's 2 years, there's 1 year, and as always, this is 0. Okay, so let's do our little qualitative check. So we put 15.7 thousand into it. How much are we going to get back? 18. 18 is more than 15.7, so we're going to get back, if all goes well, we're going to get back more than we put in. So our qualitative analysis is working with our time value of money mathematics. All right, so you all know the interpretation of this. We have the two portions and et cetera, et cetera. Okay, but let's go to part C. We only have $15,000 in our hot little hands to participate in this deal. So can we participate? No. All right, we can't do it because we need 15 plus K and we only have 15K. So not going to work for us. All right. Let's do another example while we're on the roll here. So Zero Motorcycle Street Fighter S is available at Amazon for $9,000. Okay. Rent-A-Center is offering the same bike for 0 down and 2 uniform annual payments of $6,000 starting a year from now. Okay. Your bank gives you 10% annual interest on your savings account. So let's find out, should we buy the bike from Amazon, off of Amazon, or from Rent-A-Center, and why? And for the Rent-A-Center option, let's assume that at this moment, we're going to put enough into the 10% savings account now so that that will grow to enable us to make these two $6,000 each payments a year from now and 2 years from now. All right, so let's think about this. Okay, so for the Amazon project, that's a pretty simple project. All there is CF0, and that's 9K. So we have to compare both of these projects, and the way to do that is to say, how much would we have to take from our nice pile of cash right now to make this project work? So with Amazon, we just give it to Amazon, we get the bike, and that's 9,000K. And then for Rent-A-Center, the question is, how much do we take out of our big pile of cash here sitting in our living room and put into that 10% savings account? So it'll grow into 6,000 in a year and another 6,000 in 2 years. Okay, so we have CF1 equals CF2 equals 6K. All right, so we need to know what CF0 is in this case. Okay, so for rec, CF0 is going to be equal to one of those 6,000 discounted by 10%, and that would be our starting point, tranche A, and then another 6,000 discounted by 10% for 2 years, and that would be our tranche B. Okay, so that's going to be 6 over 1, 1 plus, let me remind myself of the interest rate, okay, that we're getting from the savings account. So that's 10%, and that gets discounted back by 1 year. And the second one we have here, 1 plus 10%, and that gets discounted back by 2 years. And that is tranche A and plus tranche B. All right, so once again, we're going to take this into Excel and see what we get here. All right, we get 10.41 thousand. Okay. All right, so if we go the Amazon route, we're out $9,000, we get the bike, right? If we go the Rent-A-Center route, we get the bike at t equals 0, but we have to put $10,400 and change into that savings account. So that's more money, so the Amazon option is best. Okay, so buying from Amazon, ticker symbol AMZ, is best. Why? For the rack option, we must set aside more cash than for a MZ option. Okay, and that's the deal. All right, so we have a couple of gray pages here, so you know what to do with gray pages, just ignore them. Okay, and then let's move into constant cash flow, excuse me, project types, also called in many textbooks annuities. And before we do that, let's pause here and take a break. This is a really good spot to take a break. So we'll do that and we'll be back shortly. See you soon.